Elle, you're under no obligation to do this, but would you mind submitting yourself to a test of your chemistry skills?
Ah! He's clearly trying to catch me off guard. Everyone who's Kira is shit at chemistry. I guess I'll have to look at them. Sure. Why not? I don't mind a little bit of chemistry.
Okay then, Light. How will I this question?
This appears to be a multiple choice question. It says, this graph represents the yield of equilibrium reaction at different temperature and pressure conditions inside a reaction vessel. Oh, so it does. Which of the following reactions would produce the trends shown in the graph? Oh, I see. It's multiple choice.
Yes, Elle. Better pick wisely.
Well, can I see my options?
Yes, of course.
Let's see. So, we have our yield of Z on the y-axis, and our temperature on the x-axis. And these different lines are these metrics at different pressures. Interesting. Alright, well, I guess we'll kind of have to figure out whether Z is exothermic or endothermic first, because clearly our temperature is affecting our yield, even at constant pressure. Well, as we go to the right, or increase our temperature, it's actually decreasing our yield. This must mean that, using Le Chateliers' principle, the system is opposing the change by creating less of Z. This means Z must be endothermic. How do you like that, L? Oh, L. Clearly, Z must be exothermic. Otherwise, when we increase the temperature, the forward reaction would be favored and we'd get more of Z instead of less of it. So, can't be A and it can't be C.
Seems his deductive reading skills are better than I anticipated. Well, he won't get this next one. How is he gonna correlate the amount of pressure with the yield of Z? I've got this in the bag. Clearly he's Kira.
Well, what else could we deduct from this graph? Oh, that's right, the pressure. At 30 atmospheres, it looks like we don't have much yield, even at low temperatures. But as we increase to 100, and even 200, we see our yield is increasing dramatically. This must relate to Le Chateliers again. As we increase our pressure, we're getting more of Z. This must mean that creating more of Z is opposing the change in pressure. Which must mean, that's right, Z has less moles than X and Y combined. Which means, let's count up. Let's look at B. 2 moles, 1 mole of X, 1 mole of Y, right? And then 2 moles of Z. That's even. That wouldn't affect equilibrium at all. Which means it has to be D. 4X plus 2Y, that's 6 moles in equilibrium with 3Z. Yes, that's right. Because there'll be less of Z, creating more of it will decrease the pressure, therefore opposing the change. Which means the answer is D. I've got you now, Al. How do you like that? This is my perfect victory. Oh, well, since in the answer B, there are equal moles on either side of the equilibrium equation, it can't be that, because that pressure wouldn't affect it at all. So, clearly the answer is D. And we can see this if we count the number of moles on either side of the equilibrium equation. Trivial.
Well, I have to say, Light, you've done rather well for yourself. I guess I shouldn't have doubted you. Anyway, thanks for doing my chemistry homework for me. I'll be on my way now.
Wait. What do you mean? Are you telling me this wasn't a test at all? It was just... Oh, I'm such a bum-ass, moronic new motherfucker. This guy... I've been played. It was a trick.